Calculus is an important branch of mathematics. It has got wide applications in physics. In this video, I'm going to give some examples. In physics, work done by a force is the dot product of force and displacement. When you take the dot product, it is F dx cos theta. Here, dx vector, that is a displacement. Force and displacement need not be in the same direction. Theta is the angle between force and displacement. Now let us consider a special case where force and displacement both are in the same direction. Suppose a force of 5 Newton is acting on a body and body is moving a distance of 3 meter. Then work done is F into x, because in this case theta is 0, cos 0 is 1, then F into dx. Here force is a constant force. Then force is constant, we can multiply F into F and x, Fx. Otherwise it is F theta 0, cos 0 is 1, so dw is F into dx. When force is constant and force and displacement both are in the same direction, we can write F into x. Here a force of 4 Newton. Suppose a force of 4 Newton is acting on a body and body moves through 3 meter. Now W is equal to F into x, so force is 4 Newton into 3, 4 into 3, 12. Work is measured in joule, so 12 joule. Now that can be represented on a graph. Displacement is marked along the x-axis. So now here x is 1, 4, then 4 minus 1, 3, so displacement is 3. Body is moving from a point 1, so this is the 0, 1, then 2, 3, 4. It is moving from the position 1 to 4, that is displacement is 3. 4 minus 1, so this is 3. And force is 4 Newton. So 4 into 3, 12. Now area of this rectangle is also 12, 4 into 3, length into breadth, 4 into. So from this is clear, work done by a force is the area under this graph. Suppose now the force is not a constant force. Force is not constant. When force is not constant, graph will be like this. It's a function of displacement, f of x. Here it is a constant. Force is a constant, so f is equal to 4. You are getting a straight line parallel to x-axis. When force is going on changing, it can be represented. Now instead of f into x, now f into dx. It's a one-dimensional motion. So one-dimensional motion, it is f into dx. Then body f into dx. Then body is moving from the position A to B. So we have to integrate between A and B. So in physics, work is the area under this graph, and that is given by this integral f of x dx, A to B. Work is given by the area under the force displacement graph. Force is marked along the y-axis, displacement is marked along the x-axis. So W is equal to integral of f dx, where x changes, displacement changes from A to B. Now let us see one more example. Impulse. If a very large force is acting for a short interval, it is called the impulsive force. Then impulse of an impulsive force is defined as the product of force and time. Suppose the force is constant. If force is constant, we can multiply F into T. Suppose force is not constant, it is changing with the time. So you mark the time along the x-axis, force along the y-axis, so you'll get a graph. This is a function of time. Force is a function of time, so this is the graph. So you have to find out the impulse for a short interval, that is f of t dt is a interval. For a force, for a small interval, f of t dt, then impulse is integral of f of t dt, where time changes from 0 to t1. So impulse of an impulsive force is given by the area under the force time graph. I hope you have understood the concept. Thank you for watching.